So the answer to the duct heater question is that the current will go down if the voltage is decreased. That is so because the original rating of the duct heater was 5,000 watts at 240 volts, which means that if the duct heater is connected across 240 volts, it will output 5,000 watts, and the current draw will be 21 amperes, as shown by the diagram. Mathematically, this is expressed as P equals 5,000 watts. The I is going to be P over E, which is 21 amperes. And the E obviously is 240 volts, so therefore we have 5,000 watts divided by 240 volts. And if we wanted to find the resistance, we would see that it is E divided by I, which is 240, divided by 21 amperes, which is about 11.4 ohms. And that resistance value is fixed, regardless of the voltage that is applied. When that same heater is connected across 208 volts, it pulls 18 amperes because P equals I times E. We found I by knowing that the resistance is 11.4 ohms. So we know that I is going to be E divided by R, which is 208 divided by 11.4 ohms, which equals 18 amperes. We found 3,744 watts to be the power at 208 volts because I times E equals the power. Therefore, 18 amperes times 208 volts equals 3,744 watts. That is because the resistance is fixed regardless of the voltage. Similar to the 240 volts, the resistance still remains the same. However, the current is decreased for the from the 240 volts to the 208 volts. The current has been decreased with the voltage because of the fact that the resistance remained constant, but the voltage changed. And in that case, if the resistance is constant and there is a change in voltage, then the current will also be affected. That is by a decrease in current with the decrease in voltage, and an increase in current with an increase of voltage. Therefore, the 5,000 watt heater at 240 volts no longer puts out 5,000 watts because it is no longer connected to 240 volts. Rather, it is 3,744 watts approximately because it is connected to 208 volts. Please like and subscribe my channel for more on this.